this class today we are going to see about sequential logic. Generally, the logic circuit is divided into two: combinational circuit and sequential circuit. Combinational circuit means it consists of present input and present output. So the output depends only on present input. That is, there is no storage element available. There is no feedback path. There is no memory element available. So the output at all time depend on only the present input is called as a combinational circuit. In case of sequential circuit, the output at all time depend on present input and also the past history of inputs. That is called as a sequential circuit. So, combinational does not have any feedback path, but in sequential it depends on past history of input, so we require a memory element to store those values. So, that sequential circuit is divided into two: synchronous and asynchronous sequential circuit. In synchronous circuit, Murray and Bailey circuit, and in asynchronous circuit, we are going to see fundamental mode and pulse mode. Yes, first, consists of any memory element. It does not have any feedback path. That is called as a combinational circuit. Sequential circuit which stores some elements in the form of feedback. So, in sequential logic circuit consists of a storage elements are connected to the circuit in the form of a feedback path. The storage element is capable of storing the information either in the form of ones or zeros, because in digital we are dealing only with the binary information. So the storage element is capable of storing the binary information as either in the form of 0 or 1. So the information present in the memory element at any time defines the present state of the sequential circuit. So the present state and the external circuit determine the output and next state of the sequential circuit. So we call the sequential circuit is a combinational circuit which consists of a feedback path. The information stored in the memory element is a binary information which consists of either 1 or 0. The information stored in the memory element at any time defines the present state. So the present state and the external circuit determine the output, that is the next state of the sequential circuit. This is the meaning of sequential circuit. So let me see the difference between what is meant by combinational logic and sequential logic. The output at all time depend on the present combination of input variable is called combination. The output depend not only only on present input but also on the past history of inputs is called sequential circuit. So it doesn't store anything in combination, so it is memory unit is not required in a combinational circuit. It stores the past history of input, so memory unit is required in a sequential logic circuit. It is faster in speed because it does not depend on anything. So the combinational circuit is very faster in speed. When compared to combinational circuit, sequential circuit is slower. It is very easy to design. Sequential logic is very comparatively harder when compared to the combinational circuit. So the best example for combinational circuit, we can tell it as a parallel adder. So at parallel adder means, for example, if we are doing 4 bits addition means we are going to give 4 input data, it will process the data, it will give the output at a 4 or 5. If it consists of a array, so the output may be of 4 to 5. But in case of sequential circuit, serial adder is an example we have to. Why serial adder? Serial adder means it will depend on the previous carry to. So once the first bit LSB is finished, then only it will start doing the next bit. So that is the case of a serial adder. What is the difference between synchronous? I have told in sequential circuit we are going to see about two things: synchronous sequential circuit and asynchronous sequential circuit. So memory elements are clocked flip-flops. In asynchronous is either unclocked flip-flops or time delay elements we are going to use. The change in a memory element, the change in the input signal can affect the memory element because of the clock signal in synchronous sequential circuit. In the change in the input signal can affect the memory element at any instant of time. Here only during the activation of clock signal only it affects the memory element in synchronous, but in the case of asynchronous it can affect at the instant of time. The memory element, the changes in the input signal can affect the memory element at any instant of a time. So the maximum operating speed of the clock depends on the time delays. Here, because of the absence of clocks, it will operate faster when compared to the synchronous sequential circuit. Synchronous is very easier to design, whereas asynchronous is more difficult when compared to synchronous. But it is also easy, we can tell like that, but when compared to synchronous, it is difficult. That's all. Next thing we are going to see about clock. Clock, what is meant by clock? Is a particular type of a signal that oscillates between high and low state, and it is utilized to coordinate the actions. A clock signal is a particular type of a signal. It is one of the signal that oscillates, that moves from high to low. High means value is 1, we know that. Low means value is 0. So that moves from 0 to 1 state or 1 to 0 state, vice versa. So that is that to coordinate some actions. That is called as a clock signal. It is a particular type of a signal that oscillates between a high and low state and is utilized to coordinate the action. So the time required to complete one cycle is called as a clock period or clock cycle. You can see in this diagram. The arrow represents the clock period, the time required to complete one cycle. When we call it as a one cycle, so it will start, for example, in this figure, it will start at the high state, it goes to low state, and again it goes to high state. So the time required for this complete one cycle is called as a clock period or clock cycle. Yes, we have told that for synchronous sequential circuit or asynchronous sequential circuit, we need storage elements. So the storage elements used in the sequential circuit are called latches and flip-flops, are the basic building block of the sequential circuit. We can call it as a basic building block of a sequential circuit. So latches is used in a sequential device that check for the inputs very continuously and produce energy and use the by the clock is called as latch. So only with the help of it will act. So when the enabler signal is active, then only our circuit will be in an active position, that is in an on position. When there is no enable signal, it does not affect the output. So if we are having a circuit, it consists of an input, output and enable signal. Only when the enable signal is active, the input is processed and it will use the output. When the enable signal is not activated, it does not affect any changes in input. It does not affect the output. Even though we change the input, the output is not affected in the case of latches, because latches is not dependent on a clock signal, it is dependent only on an enable signal. So we can call the permanent switch while we are using a permanent switch in our home. For example, when we are using a fan, it consists of a switch, right? When we press the switch, that is when we switch on, when we on the switch, the fan will get rotated. So it consists of two positions, high and low, that is on and off. When we on the switch, it will work. The fan will work. When we switch off, it won't work. So that is, it consists of two values. So depending on the enable, when we give a enable signal, it will activate. When the enable signal is not active, it won't produce any the output does not change. But flip flop is like a push button. So it changes the output with the help of a clock signal. Latches is independent of a clock signal, whereas a flip-flop is a dependent on a clock signal. Like our calling bell in our home. While we press, until we press that button, the calling bell will ring. When we release, it will stop working. So that is, for example, I have told, So flip-flop is used for a sequential device that normally sample its input and changes its outputs only at times determined by the clock signal. It is like a push button. So there are four different types of flip-flops we are using. SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. SR flip-flop means set reset flip-flop. We can call it as SR, that is set reset flip-flop. And then JK flip-flop, Jack and Kelly flip-flop. Next one will be D flip-flop, that is data flip-flop. Next one will be T flip-flop, toggle flip-flop. This is the one. So there are four types of flip-flops: SR flip-flop, JK flip-flop, D flip-flop, and T flip-flop. SR flip-flop stands for set reset flip-flop, JK Jack and Play flip-flop, data flip-flop, and toggle flip-flop. The next we are going to see about level triggering and edge triggering. Level triggering, the output state is allowed to change accordingly when active level is maintained at input level. Edge triggering, the output responds to changes in the output either in a positive or negative edge of a clock pulse. This is the diagram for our level triggering, pulse triggering and edge triggering. Positive level triggering, negative level triggering, positive pulse triggering, negative pulse triggering, positive edge triggering and negative edge triggering. Next we are going to see about the logic diagrams for flip-flops. As a flip-flop, we have used a NAND gate. The next will be the right hand side diagram is the block diagram, that is the logic symbol used for set and use. So the flip-flop is depend on a clock signal. So the clock signal is given as one of the input for a NAND circuit and S and R inputs. So it will produce the present state Q and the next state Q dash, and the input is reverse, and while we process this we will get a logic table like this. So yes, R is an input, Q of N is also a present state, Q of N plus 1 is the next state. So when my present state is 0 and then S and R value inputs are 0, the next state is also 0. When my inputs is 0, my present state is either 0 or 1. Is 0, the next state is also 0. And the present state is 1, the next state is also 1. There is no change. We can call this state as a no change. Next, when my inputs are 0, 1, when my present state is 0, the next state is also 0. When my present state is 1, the next state is also 0. So we can call this state as a reset state. Next, when my input is 1, 0, when my present state is 0 or 1, the next state will be 1. We can call this state as a set. Indeterminate, I didn't get a permanent output, that is a set output I didn't get when in the case of my inputs S is equal to 1 and R equal to 1. So the first, when my SR value is 0, Either my assumption, that is the present state, is either 0 or 1, there is no change in the next state. The present state and the next state are same. When my inputs is 0, 1, when my assumption, that is the present state, is also 0, 1, the next state will be in a reset condition 0, 0. When my input is 1, 0, when my assumption is 0, mean my next state will be in a set, that is 1, 1. In the case of yes and R, input is 1. When my present state is 0, 1, the next state will be an indeterminate state. This is a K-map simplification to find out the characteristic equation. So with the help of a next state, we have find out the next state equation P of n plus 1 equal to S plus R dash of Qn. A state diagram which represents the transition from one state to another state, and it is represented with the help of our excitation table. So excitation table, when my two inputs is 0, 0. So my present state is also 0, my next state is also 0. I am having the inputs 0, 0, 0, 1 here. So my S value is same, that is 0, 0. So I put 0. But when I see my R value is different, so I put X. In the case of transition from 0, 1, the S and R value is 1, 0. In the case of transition from 1, 0, my S and R value will be 0, 1. In the case of transition from 1 to 1, that is present state to next state, both S value is different. So X, R value is different. R value is same, so 0. X's value is different, so X. Next, in the case of JK flip-flop, Jack and Play flip-flop, this is the diagram. JK flip-flop implemented using SR flip-flop, and the next one will be the graphic symbol. It is dependent on a clock signal, so the clock signal is used. The characteristic table, it is similar to that of SR, but in the last case we have got the condition state as a toggle. So when my J and K input is 0, 0, when my assumption is 0, and that is my present state is 0, next state is also 0. When my present state is 1, next state is also 1. So we can call this state as a no change. When state is 1, next state is also 0. So the second state we can call it as a reset. When my input is 1, 0, so we can call the next state as a 1, that is set condition. When my input J and K value is 1, when my present state is 0, the next state will be 1. It toggles the value from 0 to 1. Like that, when my present state is 1, it will goes to the next state. It toggles the state to the next state, that is 0. That is a toggle condition. The next, we are going to see the K-map, that is 3-variable K-map, to find out the next state equation, that is a characteristic equation for the JK flip-flop. The characteristic equation will be jqn dash plus k dash qn. This is the state diagram and excitation table of a JK flip-flop. When it is 0, J and K value 0x, 0, 1x, 10, x1, 11, x0. D flip-flop, SR and JK consists of two inputs, SR, JK. But in case of D flip-flop, we are having a single input. We can call it as a data flip-flop, also as a delay flip-flop. The below diagram is D flip-flop implemented using SR flip-flop and the graphic symbol of a D flip-flop. This is the characteristic table. See here, when my D value, I am having only one input. When my D value is 0, my present state is 0, the next state is also 0. When my present state is 1, the next state is also 0. So we can call this state as a, what is that, reset. When my D input is 1, my present state is either 0 or 1, the next state will be 1. It is a set. So the characteristic equation, the next step with the help of a two variable came up. When we simplify the next state values, we will get the characteristic equation q of n plus 1, that is the next state as D. And then state diagram and then excitation table value for a D flip-flop is 0101. Toggle flip-flop, this is the fourth type of a flip-flop. Using JK flip-flop, we can implement toggle flip-flop, and that is a graphic symbol of a T flip-flop. So this is also having a single input T, either the T value is 0 or 1. When the T value is 0, when my present state is 0, 1, the next state, that is no change, 0, 1. When my T value is 1, when my assumption, that is some present state is 0, 1, it toggles the next state, so it produces 1, 0. When we substitute this, the next state value in a gamma, by simplification, we can get the equation q of n plus 1, that is the next state value as p qn dash plus t dash qn. A diagram and excitation table. We can convert. There are 12 types of conversion. So we can convert from one flip-flop to any other flip-flop. SR to JKDT, JK to SRD, SRDT, T to we can convert any flip-flop to any flip-flop. So there are 4, so we are having 12 types of conversion. This is a sample example. So how to convert one flip-flop to another flip-flop. So our example here, we are converting SR to JK. So first we have to write the characteristic table of a JK flip-flop. So the characteristic table of a JK flip-flop consists of JK inputs, present state q of n and next state q of n plus 1. With the help of present state and next state of JK, that is q of n and q of n plus 1, we have to use the excitation table to fill the flip-flop input S and R. The next step, we have to find out the K-map simplification, and we have to find out the equation, and then we have to draw the logic diagram. The next thing we are going to see about Murray model and Mealy model. Murray model, the output at all time depend on the present state of the flip-flop is called as a Murray model. Mealy model, the output depend both the present state and also on the input. See in this diagram, here the output depends only on the values that is coming out from the memory elements. So it depends only on the values that is coming out from the memory element. That is on the present state of the flip-flop. That is called Mealy model. In Mealy model, when we see this diagram, the output depends on the input and also the output of the memory element. So we can call it as the output depend on inputs and also the present state of the flip-flop. That is called as a Mealy model. This is the difference between Murray model and Mealy model. The function, the output is a function of present state only is called as a Murray model. Is a function of present state as well as present input is called Mealy model. Input changes does not affect the output, that is called Murray model. Input changes may affect the output of the circuit, that is Mealy model. It requires more number of states for implementing the same function, but it requires the Mealy model requires a less number of states for implementing the function. Next thing we are going to say that the transition of the sequential circuit. This is the transition between the stages indicated by the directed lines that connects the circles. So the binary number inside the circle identifies the state represented by the circle. With the directed lines are labeled with the two binary numbers. One will be the input, another one will be the output. The first one will be the input and the output value will be the next one. So it is separated by a bar symbol. So this is an example for Mealy circuit and Murray circuit. When we see the left hand side diagram, that is a Mealy circuit. Here the circle represents the state. So it consists of four states A, B, C, D, and the arrow mark represents the transition from, that is the transition line from one state to another state. And then it consists of two binary numbers separated by a bar. So the first one will be a input and the next one will be a output. Mealy circuit having different outputs. So we represented the output in outside, but when circuit the 0 or 1, we can get the same output is represented inside the state, that is inside the circle. Next one is the state table. It represents the relationship between the input, output, and flip-flop. Behavior. It is a pictorial representation that represents the behavior, whereas the state table represents the relationship between input, output, and flip-flop state. So it consists of three sections: present state, next state, and output. So present state and so when we see the first table, we are having different outputs when x is equal to 0 and x is equal to 1. So we can call it as a Mealy circuit. Mealy circuit consists of a different outputs. When it is a Murray circuit, we have a same output either where x present state value is 0 or 1. It consists of the same output, that is called as a Murray circuit. Yes, let me see. There are some MCQs on this. Yes, the first one, and yes sir, yes sir means SZ latch. What is SR latch? It is a combinational circuit, or it is a synchronous sequential circuit, or it is a memory element, one bit memory element, or a one clock delay element. So we have told latch and flip flop are the memory element used in our sequential circuit. It is one of the most building block of our sequential circuit. So we have to pick the option. The answer for this question, and SR latch is a one bit memory element. So SR latch is any latch, SR latch, JK latch, D latch, T latch is a one bit memory element. So latches and flip-flops are the most building block of our sequential circuit. With latches and flip-flops are the memory elements we are used in our circuit to store the binary information, that is the past history of our inputs. So NSR latch is a one bit memory element. Let me move to the next question. A switch tail ring counter is made by using a single D flip flop. A switch tail ring counter. So it is a ring counter. We know that ring counter counts the values, ring counter, the output of the last flip flop is connected as a input to the first flip flop, that is called as a ring counter. A switch tail ring counter is made by using a single D flop. It is a switch tail ring counter is constructed with the help of a single D flip flop. So the resulting circuit, what is the resulting circuit will be either SR flip flop, JK flip flop, D flip flop, T flip flop. The option is D. So it toggles the value. So it will produce a toggle output. So the option is T flip flop. A switch tail ring counter is made by using a single D flip flop. The resulting circuit is a T flip flop, toggle flip flop. A master slave JK flip flop or a master slave flip flop has the characteristic. Whatever the master will tell, the slave will act upon for the master's instruction. That is called the master slave JK flip flop. Let me see what are the options available. The first option, the question was the master slave flip flop has the characteristic that changes in input immediately reflected in the output. That is the first option. Option 2, changes in input, changes in output occurs when the state of the master is affected. The third option, change in output occurs when the state of the slave is affected. both the master and the slave affected at the same time. So the correct answer is C. A master slave flip flop has the characteristic that change in the output occurs when the state of the slave is affected. When the master will tell the instruction, the slave will act upon the master instruction. So, when the slave will get the instruction, it will process and produce the output. So, the changes in the output occurs only when the state of the slave is affected. So, that is called as a master-slave flip-flop as the characteristic that changes in output occurs when the state of the slave is affected. So the option is C. Correct answer is C. Next question. The characteristic equation of any flip-flop describes the dash of the next state in terms of present state and inputs. So the characteristic equation of any flip-flop describes the dash of the next state in terms of present state and inputs. Impact, behavior, path, all the above. The option is correct answer is B. The characteristic equation of any flip-flop describes the behavior of the next state in terms of present state and inputs. Let me move to the first question. How many types of sequential circuits are there? So we know that synchronous sequential circuit and asynchronous sequential circuit 2. So the options are 2, 3, 4, 5. So the correct answer is 2. There are two types of sequential circuit. The logic circuit is divided into combinational circuit and sequential circuit. The sequential circuit is divided into two: synchronous sequential circuit and asynchronous sequential circuit. So the answer for this question will be 2. There are two types of sequential circuits. How many types of flip-flops are? 2, 3, 4, 5. These are the four options. So we are having four types of flip-flop. SR flip-flop, JK flip-flop, D flip-flop, T flip-flop. Z3Z flip-flop, JK, Jack and Delay flip-flop, data or delay flip-flop, toggle flip-flop. 4 is the correct answer, so the option is C. How many types of flip-flops are there? We are having 4 types of flip-flop. The seventh question. In JK flip-flop, no change condition appears. No change. I have told the condition, the state. This will be the state, condition. The state we have seen while seeing the characteristic table of each and every flip-flop. So for SR flip-flop, we have seen no change, reset, set, indeterminate. For JK flip-flop, we have seen no change, reset, set, toggle state. So like this, they have asked a question from JK flip-flop. In JK flip-flop, no change condition appears when what is the input, that is J and K value. When first option J is equal to 1, K is equal to 1. J is equal to 1, K is equal to 0. J is equal to 0, K is equal to 0. J is equal to 0, K is equal to 1. So the option will be C. J is equal to 0, K is equal to 0. When J and K inputs are 0, I get no change. When my J and K input 0, 1, I will get reset condition. When my J and K value is 1, 0, I will get set condition. When the J and K value is 1, I will get toggle condition. So the answer for this seventh question, no change condition appears in JK flip-flop when J is equal to 0 and K is equal to 0. So the correct answer is C. In D flip-flop, D stands for data flip-flop or delay flip-flop. So the option here available is distant, data, difficult and desired. So we are having the option data flip-flop. So the correct answer is B. D stands for data flip-flop. The next question. The state diagram given below belongs to which model? When told about Murray model and Mealy model, a Murray model will have the common, that is stable output when x is equal to 0 and x is equal to 1. So it belongs to stable output will be represented inside the circle. So when x is equal to 0 and x is equal to 1, we are having the same output. So the given state diagram represents the Murray model. So the correct option will be A. But in case of Mealy model means we will get a transition. In transition we will get a label input by output value. That is two binary information separated by a slash. That is represented Mealy model. But in the case of this, we will get the output. Murray model, we will get the output inside the state. That is represented inside the state. That is represented inside the circle. So the correct option will be a Murray model. So in this class, we have seen about what is mean by sequential circuit, what is the difference between combinational and sequential, synchronous and asynchronous, clock signal, clock period, lattice and flip-flop, types of flip-flop, level triggering and edge triggering, SR flip-flop, characteristic equation, truth table, state diagram, excitation table, JK flip-flop, characteristic table, characteristic equation, state diagram, D flip-flop also the same thing, P flip-flop also, and then conversion from one flip-flop to another flip-flop, Murray model, Mealy model, difference between Murray model and Mealy model, state diagram, what is meaning of state diagram, a simple example and a state table definition, and this we have seen MCQs, and SR labs is a one-bit memory element. Transmission power is by using a single D flip-flop. The resulting circuit is a T flip-flop. A master slave JK flip-flop has the characteristic that change in output occurs when the state of the slave is affected. The characteristic equation of any flip-flop describes the behavior of the next state in terms of present state and input. There are two types of sequential circuit. There are four types of flip-flop: set, reset, jack and delay, data delay, toggle flip-flop. The no change condition occurs when j value equal to 0, k value equal to 0. D flip-flop stands for a data flip-flop and or delay flip-flop, and then the state diagram represents the Murray model because the output when x is equal to 0 and x is equal to 1, the output does not change, so the output is represented inside the circle, that is inside the state below the state name, that is state name below. So it represents the given state diagram represents the Murray model. When in the case of a Mealy model, the output will be represented. It consists of different outputs when x is equal to 0 and x is equal to 1. So that is in the case of a Mealy model. So thank you